Now let's consider a composite function problems when graphs of those functions are given. Here we have two graphs, y equals to f of x in red and y equals to g of x in blue. And we have to draw some information out of these two curves. A and B are about finding out function value, f of g of 2 or g of f of 1. How do we do that? These kind of problems are more or less related to this kind of problem here. When you have graph of a function, how do we find out a function value? Well, we have to get x coordinate, x equal to 3, and go to appropriate place in the graph and then find out the y coordinate value. Basically, that's what we did, didn't we? X equal to 3, so we start from 3 on this x coordinate axis and then move vertically until you reach the point on a graph and read the y coordinate value, because function value is y coordinate. We have to do something similar because we are reading graph and then we are looking for y coordinate value, function value, except that this time we have two functions to work on, so we have to do it in multiple steps. Here we go. We want f of g of 2. We have multiple parentheses, so the typical technique is to start from the inside. So what is g of 2? In order to find out g of 2, which graph do you have to look at? Red graph or blue graph? Blue graph is g, so let's look at blue graph and start from x equal to 2, move vertically to find out the appropriate point on the graph, on the blue graph. And here's the visualization. Start from x equals to 2 on the x-axis, move vertically to get to the point, and then the y coordinate value, function value is 3. So what do we get? G of 2 is 3, as we see here. So what we have? We have the inside straightened out. But that's not the answer. 3 is not the answer. F of g of 2 is f of 3 because inside is now straightened out. But we have to find out f of 3. And that's going to be answered by the graph of f, the red graph. That's why I highlighted in red in the next step. And that's explained by this graph here. I highlighted red one in bold because that's the graph we have to look at. And we have to start from x equal to 3 because previous step started from x equal to 2 and then got g of 2 equals to 3. And we are looking for f of 3, so we are starting at 3. So x equals to 3, as we can see, as we can see in this dotted arrow, move vertically and then go to appropriate place on the graph, and y coordinate there is 4. That's the function value, and that's the final function value, and that's the answer. The answer is 4. Now, if you have one more function to compose, then basically we'll have to do this again. Follow it again, and then you can handle not just f circle g, but f circle g circle h or something like that, or f circle g circle f, things like that. Okay, the next problem is pretty much the same. G of f of 1, basically what you need to do is follow graph of f first, get the inside straightened out, and then look at the graph of g. I'll leave that to you. And let's move on to the inverse problem. And let's look at this problem. G of f of x is equal to 3, and then let's find out x. Pretty similar to the kind of problem we studied before. No. Here. Here. And when we had h of x is equal to 4 and we are looking for x, how do we handle it? We have to find out points where y coordinate value is 3 because y coordinate value is 4 because that's the function value, and we have these crossing points, and we can find out their x-coordinate values, 1, 3, and 8 respectively in this particular case. We have to do something similar with that composite functions. Okay, let's go back. Go to this problem, and then we start from g of f of x. So g of f of x is equal to 3, and this time we have to start from backward because information is all the way outside. It's y-coordinate value, and if we start from 3, outside is g, we have to do that first, and then go inside, we have to take care of f, and then go inside, and finally we can find out what x is. So which graph do you have to look at? Do you have to look at blue or red? Outside is g, so we have to look at blue graph, graph of g. In short, we have to do something like this. Y-coordinate is 3, so you have to draw a horizontal line at y equals to 3, and you see this green line, and that crosses the thick blue graph at 2 places. One place 1, 3, and second point 7, 3. So x-coordinate are 2 and 7 respectively, but this is not g of x we are looking for. We are looking for g of f of x, so that inside f of x is equal to 2, or f of x is equal to 7. We do not have the answer x equals to something right away, but we have, well, a equation, actually a couple of equations. F of x is equal to 2, 1, f of x is equal to 7, and we have to do this all over again, this time with graph of f, the red graph. That's gonna be the next step here. When f of x is equal to 2, what we have? Well, we have the answers over here, but here's the justification. Let's look at this time red graph, because f of x is equal to 2 and graph of f is the red one, and draw the y-coordinate is equal to 2, so we have this green horizontal line, and let's look at the crossing points. We have 4 crossing points, and none of them is the lattice point, so we have to do some estimation. Roughly speaking, x is around 0.3, and then 3.7, and about 4.6 and 7.4 respectively. So that's the estimation I could do, and if you estimate a little bit differently by looking at different angle or something, it's okay. This is estimation anyway, you're gonna get full credit anyway. Instead of 0.3, if you write something like 0.9, clearly that is not the case, so I'm gonna take off some point, but if you estimate it as 0.25 or 0.4, something like that, or 1/3 or 1/4, and I'm going to give you full credit. Never mind about that. Any kind of estimation will do. In any case, we have to have this horizontal line and those 4 crossing points. Okay, that takes care of one of 2. F of x is equal to 2. And the other was f of x equal to 7. By the way, let me remind you, where in the world did I get f of x equal to 2 and f of x equal to 7? We started from function g, and then y-coordinate value is 3. So we have this horizontal line, and we had 2 crossing points, and one crossing point has 2, so we have f of x equal to 2. The other crossing point has x-coordinate 7, so we have f of x equal to 7. We already took care of f of x equal to 2. Let's go over to f of x equal to 7, but that's much easier because there's no such crossing point here. When y-coordinate is 7, we have this green line, which is really the top edge of this. And then if you look at this red graph, that red graph will not reach that high. So there's no crossing point, so no such x-coordinate will coming out of this. So the answer will be just these, 0.3, 3.7, 4.6, and 7.4, approximately speaking. You can do something very similar to the other problems too. F circle g is equal to 5, and find out x value. F circle f of x is equal to 4, finding out x values. This one you'll have to look at red graph first because that's outer function, and the blue graph in the second step. This time it's a composite function, but we are looking at just f, red graph only, no blue graph, so that's going to be a bit easier. I'm going to leave these two problems to you. Okay, we have a little bit of time left, so let's do a little bit further exercises. And these can be a bit too deep, so I have to make sure that I do not go too much. The reason I'm trimming some things out is because this is the last semester that we are going to be covering Math 1650 pre-calculus. From next semester on, we'll have just college algebra and then trigonometry and then just up. So there is relatively little motivation to do as much as we used to do. Okay. So I better not go too deep here, but to a certain degree I have to. Let's see. Find a domain in which the given function is 1-to-1, blah, blah, blah. So this is about the domain problem. 7.2, find the domain of the given function. Again, it's a domain problem. 7.3, find the domain of the given function, and these functions are far more complicated. Again, domain problems. So all these are domains, and domains are always big deal in pre-calc. Now, how do we handle a problem like this? If you plot this function, we're going to get something like this. And this is clearly not a one-to-one function, as you can see. It'll fail the horizontal line test. But if we cut right at the vertex and then take one side, typically it's easier to take right-hand side, because if you take the left-hand side half, then you'll have too many negative numbers flying around. So it's easier to take the right-hand side. If you do that, if you restrict the domain, obviously, apparently, that domain will be x is greater than or equal to 1. If I do that, then I'm going to get a one-to-one function that passes horizontal line test and will be able to figure out the inverse function. So how do we do that? It goes kind of like this. Y is equal to negative 3x squared plus 6x plus 5, but first two terms can be factored out kind of like this. Negative 3 is out, and we have that. And then let's make it into a complete square. X squared minus 2x, so plus 1 minus 1, so that I don't change anything. Plus 1 minus 1 is 0. But if you take x squared minus 2x plus 1, that's going to give me a complete square. So x squared minus 2x plus 1. And then how do we get this negative 1 out? Well, distribute negative 3, so we have plus 3 plus 5 is what we're going to get. As a matter of fact, I made a sign mistake here. That should have been negative 5, excuse me. Yes, I should have started with negative 5. Okay, and this one is a complete square. It is x minus 1 squared. And then 3 minus 5, so that's going to be minus 2. So here is the vertex form of that function g. And, oops, okay, that's how we can find out when x is greater than or equal to 1, this h value, then we have the right-hand side half of this parabola, and we have one-to-one function. And that's how we can get the domain of this function. X is greater than or equal to 1, and the range of this function is y is less than or equal to negative 2. So that's going to be the domain of the inverse function.